This is the modern periodic table. 118 elements are arranged in the periodic table in a very systematic manner. There are some properties which are related to these elements which define the way in which these elements react. Since the elements are arranged in a very well organized manner, even these properties follow some particular trends. Let's see how. One such important property that is related to the elements is their ionization energy, that can be abbreviated as IE. It's also known as ionization potential. Ionization energy is the energy required to remove an electron. So the electrons move around the nucleus of an atom. So to remove an electron requires some energy. This energy, which is given to the atom to remove an electron from a neutral gaseous atom. We talk of gaseous atom because we want to say that the atom is isolated. In liquid or solids, it is related or it is associated with some other atoms. So we do not talk of the liquid or the solid atoms. So to specify that the atom is isolated, we say that the energy required to remove an electron from a neutral gaseous atom, and since we remove an electron, it converts it into a positively charged ion. Since we are taking a gaseous atom, so it converts it into a gaseous ion. So to remove an electron from an atom requires energy, and this energy is known as the ionization energy. So there's an atom, you provide it with ionization energy, and this helps to remove an electron from the atom. When this electron is removed, we are left with a positively charged ion. So let's see how this ionization energy varies in a periodic table. We know that atomic size decreases on moving from left to right in a period. Also, atomic size increases on moving from top to bottom in a group. So when we move from left to right in a period, the atomic size decreases. That means the outermost shells are pulled with a greater force towards the nucleus. Since the outermost shells are very close to the nucleus, so it requires a lot of energy to remove the electrons from this shell. Since now the energy required to remove the electrons increase, therefore the ionization energy on moving from left to right in a period increases. So let's revisit how the ionization energy varies in a period. We know on moving from left to right in a period, the atomic number increases. As the atomic number increases, there's increase in the nuclear charge of an atom. This increased nuclear charge tends to pull the outermost shell closer to the nucleus, so the atomic size decreases. As the atomic size decreases, electrons are held tightly to the nucleus, and therefore we require greater energy to remove the electrons from the atom. And since the energy required to remove the electrons increase, that means the ionization energy increases when we move from left to right in a period. In a neutral atom, we take magnesium. It has electronic configuration 2A2. In a neutral atom, the number of protons is equal to the number of electrons. So this is for magnesium. Now, if we remove one electron from the magnesium atom, we get a positively charged ion, Mg+, which has electronic configuration 281. Now in this case, the number of protons is one more than the number of electrons. So in effect, the nuclear charge which is exerted by this nucleus on the electrons increases. Since the number of protons is now more, it exerts a greater pull on the electrons in these shells, and so overall the size of the cation decreases. So whenever an electron is removed from a neutral atom, the net effect of the nucleus on the electrons revolving in the shells increase. They exert a greater pull on the shells, and therefore the size of the cations decreases as compared to the neutral metal atom. So the cations are always smaller than the neutral atom. Let's say IE1 is the amount of energy required when we are removing one electron from an atom, and IE2 is the amount of energy required to remove the second electron from the atom. So what do you think? Is IE2 more, less, or equal to IE1? Let's see. We know when we move from left to right in a period, the atomic size decreases, due to which the ionization energy increases. And right now, we saw that the cations are always smaller than the neutral metal atom. Since the cations are always small, so whenever we remove one more electron, so the size of this is less, the size of this cation would be even smaller. So as the size is decreasing, the ionization energy is increasing, because as the size of cation decreases, the outermost shells are closer to the nucleus. So it becomes very difficult to remove the electrons. So the successive ionization energies, that is, to remove the first electron, this amount of energy is required. When you remove the second electron, you know that the cation becomes smaller in size, and therefore its ionization energy will increase. Further, if you remove the third electron, the size of the cation decreases further. Since the size of the cation decreases further, the energy required to remove the electron will further increase. And so, therefore, the successive ionization energies increase in value. What happens when we move from top to bottom in a group? We know when we are moving from top to bottom in a group, the atomic size is increasing. This leads to a greater distance between the outermost shell and the nucleus. Since the distance between the outermost shell and the nucleus is increasing, this electron needs lesser energy to be removed. Since this needs lesser energy to be removed, as it is away from the nucleus, the ionization energy decreases. As the size on moving from top to bottom in a group increases, the outermost shell electrons are away from the nucleus. So to remove the outermost electrons, we need lesser energy. And so on moving from top to bottom in a group, the ionization energy decreases. Let's revisit how there is a change in the ionization energy when we move from top to bottom in a group. So we know that nuclear charge increases when we move from top to bottom. Also, in a group, the number of shells increase successively. The increased nuclear charge has an effect that it tends to pull the outermost shell closer to the nucleus, but the increase in the number of shells overweigh the increased nuclear charge. So in effect, the atomic size increase due to the increase in number of shells. As the atomic size increases, electrons in the outermost shell are held loosely, since the effect of the nucleus on the outermost shell decreases. So to remove the electrons becomes easier, and we have to provide it with lesser energy. As lesser energy is required to remove the electrons, so the ionization energy on moving from top to bottom in a group decreases. So we have these three elements: beryllium, magnesium, and calcium. We have to arrange them in the increasing order of ionization energy. Let's try to locate these three elements in the periodic table. So we have beryllium, magnesium, and calcium. They lie in a group. So we just saw that when we move from top to bottom in a group, the ionization energy decreases. This is because the distance between the nucleus and the outermost shell increases. Lesser energy is required to remove this electron from the atom, and so the ionization energy decreases. So to answer our question, we know that these lie in a particular group. So from top to bottom, we know ionization energy decreases. And so we have calcium, its ionization energy is lesser than magnesium, and its ionization energy is less than beryllium. So this is how we arrange beryllium, magnesium, and calcium in the increasing order of their ionization energy. So in a periodic table, when we move from left to right, the atomic size decreases. The decrease in atomic size tends to bring the outermost shell close to the nucleus, so it becomes difficult to remove the electrons. Greater energy is required to remove the electrons, and so the ionization energy increases. When we move from top to bottom, the atomic size increases. This tends to loosen the electrons which are away from the nucleus. As the electrons, the outermost electrons are away from the nucleus, lesser amount of energy is required to remove them, and so the ionization energy on moving from top to bottom decreases.